I don't know.
There's one behind you.
Yes, we have one! You are amazing.
Okay, go.
Cool. Alright, so I'm Nicholas Craig. I'm second year in my uni degree. I've been programming... Sorry. I've been programming...
Triple the number previously.
Yes!
Yeah.
Brilliant. Yeah, I've been programming since, for 4 or 5 years, mucking around with it since early high school, year 10 sort of thing. And I'm here to talk about programming, what it is, some key concepts, fundamental ideas that will help you deal with it, and sort of wrap up with how you can get into it and what you can start doing even when you get home tonight to get involved and start actually making things and developing things. Turn the lights down. Alright, so programming. What is it? At its fundamental level, programming is all about communicating to the computer. It's a way of telling the computer what you want it to do and how you want it to respond to the user and what the user's doing and what options you want to give the user in terms of interactivity. What it's used for? Programming can be used to make games, obviously, probably what you're all here for, but it also covers things like operating systems. They have to be programmed, all of your applications, your music players, your mobile devices, applications that go on them, all of that sort of stuff, as well as things like factories, production lines. Anything electronic basically has some level of programming in it. When you're programming, there's basically only 3 things you can do with your code. You can have a sequence, which is where your code runs, first line, second line, third line, step by step. You can have a loop, where it repeats parts of that code a certain number of times, and you can have a decision, where your code will branch and either do this set of instructions or that set of instructions. And those are the 3 fundamental things that you will do and what you will tell the computer. And that's the only way that code ever works. Machines are very simple. They work on binary, 1s and 0s. Anything above that is built and abstracted out. When you're working with programs, you want to be able to store data. If you can't store data, then you've got nothing to go on. So data types comes into talking about how you want to store your data and what data the computer can store and understand and how you can then use it. The fundamental data types that you've usually got are Boolean, or bool. That represents a true-false, a flag that either says yes or no. Things that you can do with this can be player, alive or dead, is a Boolean. User has a valid login, doesn't have a valid login, true or false. You usually use it in conditions for loops. You say, do I want to do this loop again? Yes or no. Number, which covers things like numbers, obviously, player health, player shield value, anything like that. It can be decimal point numbers or whole numbers, and they all go into number type variables. You've got character type variables, which are individual letters, and due to the way it's stored, they are actually numbers, and it goes, well, the 27th character is an A or a Z, and that's how characters work. After that, you've got complex data types. So all of those are primitive and fairly easy for the computer to understand. After that, you've got more complicated ones like strings, which are collections of data, and you can make your own complex and custom data types. So you can have a player as a data type, and you say that a player has in it a number for its health and a string for its name, and a weapon as another data type for what it's currently carrying. When you're writing code, you want to write things into things called functions, because programs can get very, very large. You can have lots and lots of code, and you want to be able to shrink that down into small packets, small pieces that you can understand, and those are called functions. The key idea of a function is that it's encapsulated. It does one thing, and that is its job. So you can have functions that are take damage function, functions that swap weapons for players, functions that tell your program what the player is currently doing. And they're all small, they're all self-contained, and they all do what they're meant to do. These functions have return types, or can have return types. So if one of your functions for a calculator is add, you would have add as a function, and it would return the result of whatever the numbers were. When working with functions, also you tend to give them data to work with. So if you've got an add function, you want to say add, and I'll give you the number 5 and the number 7. Those count as parameters. Paradigms. When programming, you've got certain approaches and certain things that the environment you're using will do. Popular one is object-orientated, which says that all of my code represents real objects or abstract objects. So you can have a player as an object, and you can create instances of players, copies of them from that template. And so with something like Halo, there would be a player object that they'd written, and that would understand everything that the player could do and understand everything the player had, and every time a new person signed in, it would say, yep, I'll create a new player from that template. Games also use event-driven paradigm, which is a way of coding that says, I will listen for an event to happen, and when that event happens, I will do this, rather than other sorts of paradigms which usually are sequential, that it just goes A, B, C. So if you want to do something, you've got to be actively checking for it every time you go around. But object-orientated is the main one. With object-orientated programming, as I said, you've got objects. These objects are defined by states and behaviours. So they have states, a collection of information about what it is, what it does. I am a person object. I have a name value. I have a health value. I have an address value. And I have behaviours. I can sit down. I can pick up a pen. I can do all that sort of stuff. I can give a boring lecture to an empty lecture room. Yes. And there's another thing called inheritance, where you can say, well, hi guys.
Hello.
Hello. There's another thing called inheritance, where I can say I'm going to make a person, but I'm also going to have a student. And a student basically does everything a person does, except they've also got a school and units that they do, so you don't have to rewrite everything. When coding, you've got structures. Your structures within your code, usually you've got a main function, which happens when you run the program, like the executable for most games, and it will go in and say, okay, cool, this is what I'm doing. That function then goes and looks at all the classes and objects that you've written. And so for Halo, you put the disk in and it says, yep, I'm going to run the menu first. And then it says, okay, you're starting a new game. Well, I need to go grab some players and some weapons and all of these other classes and data objects that you've built for it to use. And all of those objects then have functions. So you start the game, it's grabbed the players, it's put the players in, and it goes, okay, well, right, you now have control of the player. When you push the bumper, you shoot. When you press A, you jump. And all of that sort of stuff. So we're going to go through an example of how you would break a program or an idea down into all of these component parts. When you're designing a game or building a game or any sort of program, you want to know exactly what you're doing before you touch the keyboard. I've seen a lot of programming assignments that people have done and projects, and they go, yep, okay, I've got an assignment, and they just go straight to the keyboard, and 3 days in, they've got no idea what they wrote the previous days, and they're trying to create this new thing that does X, Y, Z, but it doesn't work with anything they've written beforehand because they didn't plan. So when you want to build something, you've got to understand everything that it's going to have and everything that it's going to do, and have it all out on paper before you start coding. Got an example up here of Space Invaders. This is one of my lecturers did with me, about how to break the program down into its objects. So we look at Space Invaders and we say, what are the objects that we see on the screen? We can see a player, we can see ships, we can see enemies, we can see the shields, and we can see the bullets. Very simple. It's a fairly old game, so it's not too complex. More minions! Brilliant. So, okay, so every object is a self-contained, in this case, game entity. We're looking at something else. We'll look at StarCraft, and we'll do StarCraft as an example. What are some objects or things that you have in StarCraft? Anyone?
Units.
Buildings, units, yes? Anything else? Resources. Brilliant.
Automaton 2000s.
Sorry?
Automaton 2000s, the little critters.
Ah, those two, critters. Okay, so we've got units, buildings, resources, and critters, just as a basic starting point. And those are things in the game, and we want those to have things that they can do, and we want those things to more or less look after themselves once we've told them what they're doing. So for buildings, we've got a building as an object that we're deciding to code. So when we're coding this building, we have to say, what does a building need to know? What would a building need to know in StarCraft about itself or what it can do? Yes?
How to spawn units.
How to spawn units, yes. Might also need to know where it is in the game world. X and Y coordinates.
How to react to when the player's interacting with it.
Yep, interface and that sort of thing.
How much health it's got.
And how much health it's got, very good. And so that's a fairly simple object. You move on to something like units, they've got their health value, they've also got attack and defense values, so that when they're interacting with other units, they know how much they're affected. They've also got functions for telling them how far they move, and what they do, pathfinding, and all that sort of thing. They've also got, like building units, their own set of special abilities. And we can see that this is what I did last night, well not last night. Yeah, so we've got, and minerals. And one thing a mineral needs to know is how much mineral it's got left in it, and so when the workers come, they can say, yep, yoink, mine. So buildings have health, they have their abilities like lifting off, building units, setting rally points. Units have their health and their speed, their attack type, their damage, and their armour. And so when you're building a game, it's important to know everything that you want to have in it, and all of these components. Because if the guys who made StarCraft started coding, and they said, okay, we're going to have buildings, and we're going to code buildings this way, and then they go and code units, and they realise, well, the way we've coded buildings, buildings can't actually create units anymore, because we didn't think about that beforehand. Or they went with the attack and damage types. They've got like heavy armour, light armour types in StarCraft for the units. So certain weapons do more damage against heavy armour or light armour or biological or mechanical. If they didn't put that in properly, or they didn't think about it until the end, then all of a sudden you wouldn't have that. And so a unit that's good against lots of hordes of light units like Zerglings would be just as powerful against really strong mechanical units, and the entire game would be unbalanced. So if you don't know what you're doing before you start coding, you run into problems, things don't work properly. And that's a big plug for thinking about what you're going to do first before you do it. Behaviours for the units. I think we went over most of them. Units get created. Very importantly for a lot of objects. Hey guys. For a lot of objects, you've got to know what happens when it gets created. So when a unit gets created, it goes, boink, here I am in the world, have I got a rally point? It's the first thing it says. It's been created, has it got a rally point? Otherwise, it'll just sit there. They've got behaviours that let them move, let them stop, let them patrol, let them attack. Basically, all the buttons in the interface, or for games particularly, if it's the character you're controlling, every button that you can press to make it do something would be written out as a method, as a behaviour of that object. So you've got all your standard objects, and you've also got units that have special abilities, like buildings can build units, SCVs can build buildings, certain units can blink to move around, abilities like that. Cool, so this has been talking briefly about the ideas behind programming, haven't gone into any code, talking about the mindset, how you approach it, how you look at breaking a problem down into all its individual parts. If you want to actually start building things and start designing things and start getting them into the world, I would highly recommend Game Maker for a start. A lot of you have probably heard of this already. I, in Year 10, made a complete game of Space Invaders and then some with extra stuff, all in Game Maker. Didn't have to learn a line of code. Not one single line of code, and I built a game. I'll show you, it's in my showreel. So Game Maker, don't need to know how to code. All you need to know is how to approach a problem logically and maybe use the internet for a few tutorials. If you want to get into actual coding, Java, the JDK for that, I believe there's a free download, and Eclipse is the program that you write in, and that is also free download. It's what we use for our foundations of programming classes in the Monash IT. That's a very good programming language, Java for beginners, because it's got lots of things to help you out if you don't know what you're doing. If you want to do visual stuff to begin with, Flash and ActionScript, the Adobe product Flash. It's great for animation. It's got keyframing animations, it's got a graphic interface. You can draw buttons and characters and things and have them wiggling around on screen. An ActionScript that plugs into that. So that's fairly good if you want to jump straight into, you know, a bit of coding, or you're confident you want to jump straight into something that's got visuals attached to it. And if you're really crazy, you can try the Unreal Development Kit. I believe that's also a free download unless you're trying to make money off it. And I haven't had a look at that, but it's got 3D and it's got spasticness.
Get the list of games up that's made by them.
Yeah, like Gears of War was made in Unreal, I believe. Yeah, a lot of the big ones. I'll show you my showreel, just if you're interested. And then I've actually got an executable of the game I made in GameMaker, so you don't say, you know, GameMaker's crap, you can't do anything in it. Yes. Yay. There we go. I did a lot of graphic design work early days too. Should be... If you're doing a general IT degree with Monash, they get you to do a lot of stuff. You do a bit of Photoshop, a bit of web, a bit of database, just to sort of round yourself out. That is the game I made in GameMaker. It's got hundreds of different enemy types. They all do different things. You've got a ship that you can control. Yeah, GameMaker, you don't need to know any code to do it. Cool, so that was my showreel. Just a bit of background on me. I did do a lot of graphic design work through high school. Thank you. I did do a lot of graphic design work. It's something that's visual. It's nice to have just to round things out. Yeah, programming, as far as you guys are concerned, I have got the executable for the game that I made, and I'll sort of walk you through how I got the idea, the approach that I took to it, some problems I had along the way. So I decided to call it PC Protected. The original idea was, I've got the desktop for my screen, I want to do something interesting on it. So, as you saw, it's a screen simulation. This is the screen I had at the time. I was using XP, very old. And I wanted to make something that wasn't too out of the way, so I chose Space Invaders as a template. Controls for the player, move and shoot, very standard. And GameMaker will actually let you do all of these. It's got tutorials pre-written. Basically, any standard sort of arcade game template it will have for you there to pull apart and look at.
Did you use Pro or Lite version?
I used the Lite version.
Okay.
As far as I'm aware, the Pro version, the Lite version has everything you need to program games and to build things and objects and all that. The Pro version adds a few fancy features. It'll let you do particle effects. It will let you do fancy loading screens. It will let you customize the icon of your game as an executable. Yeah, I use the light version because I couldn't be bothered paying for it. And as a learning tool, it's great. I'm probably not going to be making money off Game Maker, so I don't really need the pro version. So yeah, it'll let you create objects, it'll let you tell them how to move, it'll let you tell them what to do when they collide with other objects, say bullets. And all of this is done through, for Game Maker, a really good interface. It's got a whole set of instructions listed as commands. So rather than having to go in and type out your code to tell your object that when it collides with this or that, it's got a little interface. I have a screenshot. This is the interface. And this is what you'll be using when you're playing with Game Maker. It looks a bit complicated, but it's really not. Down the left-hand side, you've got a list of all of your objects, all of your resources that you're using. And in here, here's where you code, so to speak. All of these buttons have little help text, and you just drag and drop them in, and it'll do what you want. So over here, you've got an event that says, when the player presses the spacebar, it's checking a variable, if shoot is equal to 1, and it's doing a bunch of code here, creating an instance of a bullet, I assume, setting the score. So you don't have to know any code, all you have to know is English, and you can poke through this and read the help text and say, well, I want to create a player that I can move around, so create a player. Oh, this says if they're pressing the left key. Yep, cool. When they're pressing the left key, move object. Yeah, move object to the left. Very easy, don't need to know how to code. This is Adobe Flash, that's ActionScript. So it is code, but the good thing about Flash is you get a wonderful graphic interface, and you've got animation tools, and you can attach your code to visual objects. Whereas with Java, which is the other one I recommended, what I've done is all text prompt based. Apparently doing graphics and UI and that is a bit fiddly because it doesn't do it for you, but if you just want to get into pure Java code or pure coding, that's what Java looks like. And even if you don't know how to code, you can sort of stumble your way through it without knowing anything. If you look up here, we're creating a player, private class player, so we're making a player as an object that we can use. We're giving a player a score, a name, an X and Y position, a thing to say if it's alive, a thing to say how many shots it has. And so yeah, you want your code to be readable, and most of the time the language helps you out by making everything logical to begin with. Also, all this green stuff is commenting. If you add comments, it really helps, because if I wrote this, 2 years ago, last year, a month ago, if I got drunk before or after, all these comments are little notes to me or anyone else who's going to read it, and they're just saying in plain English what you're trying to do. So I did this in first semester, and I can go down here and I can say, oh, it's creating a snark for the player, this includes alive, and doesn't include shots. So that thing is making a snark, whatever a snark is, for the player. And I can look at the codes and read through that. So if you are doing tutorials online and you don't actually know the language that they're using, hopefully the comments will still be able to explain what they're trying to do. So yeah, those are the three I recommend if you're getting started. Game Maker, don't have to know any code. Java, Eclipse if you want to get into it a bit more, or ActionScript Flash, which is a little bit harder but comes with all that nice animation and nice graphic stuff. And you can actually make Flash games come from Flash. So all of the stuff on Congregate, free online games, that sort of stuff, usually comes out of Flash ActionScript. So it is a serious tool. I haven't really got anything else to say. Has anyone got any questions?
Does programming require a lot of math?
It doesn't require a lot of math unless you're doing something that is inherently math-based, and that may not make sense. If you're programming something for engineers or something for math teachers that involves geometry, you're going to know it's going to need math to go into it. But if you're programming things like games, math isn't really that important. I mean, the highest numbers you might have will be the score, and that'll be, plus 10 every time they kill someone. The reason that math is usually a prerequisite for programming courses is because it's a similar mindset. It's about solving problems. it's about having a set of steps that you can go through. So with Pythagoras, then you've got sides of a triangle, and there's a formula for that. You plug the numbers into the formula to get the result. With programming, you've got a player, and he's got a health on one side and a score on the other side, and you have a formula to figure out their score or whether they got a new life. You plug things in. It's a similar process, but you don't have to be good at maths. Anyone else? Alright, thanks guys. It was Nicholas Craig. That was programming, a brief introduction. You guys have just come in. I'm not sure if you were for this or something after. It's all good. Yeah, I'll be around if anyone has any questions.